growth model, Harrod model. So the assumption it's closed economy for simplicity, no government interference, savings, investment, and income are adjusted simultaneously in the same period. Savings is equal to investment, average propensity to savings is equal to marginal propensity to savings, propensity to save and capital output ratio are fixed. And here consider the constant return to scale. In in the model, their output is yt at tth period. Total output yt it's equal to minimum of vkt comma blt. Here b and v are the positive coefficient. If suppose v is equal to 1 by 4, then 4 unit of capital produce 1 unit of output, and 1 by v equal to k by y, it's capital divided by output. This is a capital output ratio. And 1 by b is equal to labor divided by output, where labor l by y ratio. Now economy is overpopulated. This is an assumption. The BLT part higher than VKT because economy overpopulated. VKT it's less than BLT. YT equal to VKT because LT it's very large. So B is equal to YT divided by KT, output capital ratio. From this line, 1 by V equal to 1 by V is equal to k by y, or v is equal to y by k. This is capital output, output by capital. Same here. So yt is equal to vkt. Yt is equal to vkt, where yt is proportional to kt. K by y equal to 1 by v, it's equal to c, capital output ratio. Yt equal to vkt if capital increase by 1 unit as well as output, that is y increase by v unit. To maintain the equality, yt is equal to vkt. How? Here v it's equal to output by capital. B and v are constant. If capital increase by 1 unit, then output increase. So v is equal to y new divided by 1 plus k plus 1. Here if we multiply, then we get k into v plus v is equal to y new, and kv, we know that kv equal to y. So similarly from this line, y old plus v is equal to y new, or y old is equal to v plus kt. We know that from this uh, previous page. So v is equal to y new minus y old. So s is equal to marginal propensity to save. K depreciation, k minus depreciation is equal to 0 at time tth period. Savings equal to investment. So if increase in capital, then we can say that a small s into y is equal to increase in capital, or s is equal to capital S equal to small s into y. Increase in capital it's equal to s into y, or change in capital, that is k dot, is equal to s into v into k. We know that y is equal to y, it's equal to k into v. Here use this formula. And k dot by kt, k dot by k dot by k, from this equation k dot by k, it's equal to s into v, or s divided by c, because we know that the v is equal to 1 by c. So k dot by k is a growth rate of capital, or k hat is equal to s by c, growth rate of similarly it is also growth rate of capital. It's equal to marginal propensity to consumption divided by capital output ratio. or it is equal to growth rate of output from 2 as y is proportional to k. Y hat is equal to S by C if income grows at a rate equal to savings rate divided by the capital output ratio. This is the fundamental result of the Harrod growth model. So Y hat equal to S by C. That means savings is divided by capital output ratio. So if V, what is V? V, it's a constant positive coefficient. It is 1 by 4, and C, capital output ratio, it's 4. So S, what will be the savings rate? Or the S, the rate of growth of income is, that is, sorry, V, it's a positive coefficient 1 by 4, C is equal to 4, because we know that 1 V is equal to 1 by C, so C is equal to 4. Or S, savings is equal to 0.2, the rate of growth of income, that is Y hat, is equal to S by C, so S is equal to 0.2 and C is equal to 4, that is equal to 5%. So the rate of growth of income is 5%. If the output increase, then first our objective is to increase the savings rate and decrease the capital output ratio, and V, the coefficient, positive coefficient, will increase and capital output ratio falls from this second line. So less capital use but want to produce more output, then the capital should be more productive. So the result of this Harrod model is a country needs to increase savings rate and capital more productive to get higher growth rate. There are some cases. The first case is S, that is savings divided by capital output ratio minus N. N is the population growth rate. This is true only when there is no labor shortage. So that means, suppose if an economy N, the population growth rate is equal to S by C, as the savings rate divided by capital output ratio, then per capita income grow at zero rate. Population, capital and output all grow at the same rate. In case 2, in the population grow at n rate, it's greater than S by C. In the long run, growing unemployment, because there it's the population growth rate is higher than the this proportion. And third case is population growth rate is lower than S by C. For India, not possible, because population growth lower than the capital output ratio, not possible. So S by C, it's capital output ratio. Furthermore, per capita income growth rate is positive when capital output ratio minus the growth rate of population is greater than 0. That means capital output ratio is greater than n from this line, and income grow more proportionately than population, because capital output ratio it's more, so income will increase more than the population, so unemployment will gradually vanish. So, when full employment is reached, the growth rate of output and capital continued by growth rate of population. So, in the long run, output, capital, and the growth rate of population will be same. So this is a formal proof. We will elaborate further. That is y hat output it's equal to capital is equal to growth rate of population, and the other part will discussed in the next lecture.